classes are factories that create objects. And if you get really technical, you can say classes are objects, because everything in Python is an object. But a class is a special kind of thing whose job it is to be the specification for the creator of objects. So we make new objects with classes. And what specifically did we explore about classes? What can you do to customize classes? Right? So the basic thing we want to do with classes is package some code and some data together. The methods are regular functions, but they're attached to an object. They take a first mandatory parameter called self that refers to the object once it's actually created. We don't have to pass that parameter in. And it's a way for the methods to be directly attached to the data that they're operating on. They can set variables on self, and that's in the local namespace of the instantiated object. Methods, what methods did we talk about yesterday on classes? We talked about init. What does init do? Yeah, init is the... So you'll find out later that I've lied to you for the purposes of simplification, but yes, init is the constructor of the class. There's also an underscore underscore new method, and the deal is in Python you don't have to take your construction and destruction of your classes quite as seriously as you do in many other languages. So it's very typical not to write destructors for your classes at all, which most other OOP languages you would. And we don't actually handle the class's allocation and construction. Init really is called after the class is made, and it's a way for us to go ahead and initialize the data that should exist on every single object. If you really had to control how the class is allocated, you can use new, and you can also use... Yeah, there's a couple of complicated concepts that are way beyond the scope of the class, but you can use the meta class of the class to totally control how it's created and instantiated, and do all sorts of crazy things like returning objects that aren't even part of your class at all if you wanted to. And it's way beyond the scope of the class to discuss it. But be aware, init is not actually the constructor, but it is the initializer of your object, and it is what you're going to use 99.9% of the time to initialize your objects. Other use cases are for people who are writing complicated software that I might use. OK, so talking about other functions we talked about on classes, other methods of classes, we actually listed a whole bunch of underscore methods. And Yuli is asking kind of how are these related to one another. And we did the underscore underscore string method yesterday. We did an underscore underscore repr, R-E-P-R method. We talked about like the underscore underscore add, the Dunder add method. And there's a bunch more. They're not related to each other in any technical sense. What all the underscore methods are protocol methods. Whenever Python does stuff with your objects, it checks to see if these methods exist and uses them if they do. So Python allows you to influence how your methods respond to all the built-in operators. So converting to strings, converting to representation, responding to add, responding to the call operator, which is parentheses. You can customize how your object could handle being called. Responding to plus, to times, divide. You remember we did sets way back, and we could use functions to do things like the intersection of two sets, but we could also use operators. We could say like set1 ampersand set2, and that operator is actually a Boolean ampersand by default, and it only has meaning on sets because sets have the set class has implemented the underscore method that responds to that operator. So all those methods, they're just to allow us to customize how our objects get handled by Python.
So
yes?
there's corresponding class for any
Nope, that's we are doing operator overloading, and this is how Python accomplishes it.
Right.
Yes, it is.
Okay.
Yes. And again, it kind of works by protocol, and you can read in the documentation about the protocol, but Python will call even a succession of methods. So if you define the underscore underscore new, when you create a new object of your class, Python will call that. If you then have an underscore underscore init, Python will call that. If you didn't provide either one, it'll just make your object. Yeah. So it's protocol-based. There's no syntactic enforcement of making sure that you have a constructor or a destructor or implement any of these Dunder methods, you'll just find out about it when you try to use an operator on a object that doesn't support it, and it'll say, I'm sorry, I can't add a row in a row. That operation isn't supported. Protocol I'm using in the sense that there's a defined order of operations that Python follows, and that allows us to hook into and modify the behavior of our objects. But it's not a syntactic level enforcement at all. Yeah. And just as an example of how flexible that makes things, you can respond to the operator for brackets, for square brackets. So if you want your address book to be able to say, I got a new address book and it's A, and you could just say A bracket 1, closing bracket, you're not getting into whatever data structure you're using. You're calling a function that can get into whatever data structure you're using. So you could enable, for instance, indexing by position and indexing by name on the same object. Because ultimately being handed to a function, and the function could say, hey, if this is an integer, let's do positional. And if this is a string, let's do a key-based lookup. So you can program how your objects are going to respond to all the operators. And some things are operators that you don't think of, like square brackets, like parentheses. It's just the operator for call. And it's you can make very fluent interfaces using the Dunder methods in emulation. OK, what else did we talk about yesterday besides OOP? Now, it seems like the only thing we talked about, but we really only talked about that for like an hour and a half, maybe. List comprehension, which should be like your new best friend for life. Seriously, you should love these things. List comprehensions are indicated by what? Square brackets. List comprehensions have 3 parts, with one part being optional. The first thing in a list comprehension is, yes, basically the return value, the statement, the expression that will be evaluated and become a single item in the resulting list. And it is everything up until you bump into a 4. And it can mutate, it can change, it can just be a value from the iterable you're iterating over. The next thing is the 4, and that defines your iteration. 4 value in some iterable, enumerable. And the last and optional part is the if, the condition. You can optionally include items in the resulting list. So in a list comprehension, we can filter things out, and we can change their values in one statement. And we can nest list comprehensions, but I don't approve of that. There we go. So we talked about not just functions as first-class citizens, but higher-order functions, functional composition, factories, functions that create special case functions for us and return them, decorators, which do exactly that, but wrap the enclosing function. Decorators, we can mostly conclude, make you think when you write them, but they're trivial to use. We're going to use another decorator today as we continue doing OOP that's super useful and that's built in. We took a look at anonymous functions. Lambda. If you remember lambda, they have to be really simple, a single expression, which is implicitly a return, an optional list of parameters, no parentheses, just a semicolon separating the two things, and the keyword lambda. And we might use them as short one-liners to pass to things like filter or sort or map, built-ins that expect you to pass a function that does something simple like pick a key or return a value or compare two objects. We talked a little bit more about namespaces yesterday. Namespaces going from packages and modules, functions and nested functions, and now classes and objects. And we're ready to talk a little bit more about OOP today. I guess I shouldn't forget we did a little random coverage of the standard library. So we talked about like itertools, for instance, and the operator module as well. So in our OOP section in our curriculum, we've got the first and basic level of objects, we talked about emulation, which is the section in the curriculum that talks about the Dunder methods. Another word for that could be operator overloading, but basically how to customize the behavior of your classes in response to various operators. It's worth noting that one of the examples in the curriculum is iteration. So it shows a class, this is on page 44, it shows a class that defines an underscore underscore iter function, and that simply enables you to do things like for value in object. It'll respond to the iteration protocol. So we hadn't covered that. We might do a code sample of that today. We did talk about static method. We used a decorator. We left self off of our function. If you didn't use the decorator and you left self off of your function, when you call your function on an object, it complains because it wants to pass self. When you call it on the class, it complains because you want to pass self. If you add the static method object, or the static method decorator, you can call your function directly on the class without having instantiated an object, and that's sometimes a little bit useful. There's also the class method decorator that we could cover. If you have methods you might want to call without a class being instantiated, but you do want access to the class, why might you want access to the class? Change the common data. So objects have namespaces, and every object has its own namespace, but they also share the class namespace. So if you wrote a class method and it changed a variable on the class, every single object would see it. So there could be two ways of passing a piece of information to all the objects that exist. One might be to round them all up. Let's say you've made 20 rows. You could go through each row and give it some data. Or you could just set the data directly on the class. And you might want to do that as a class method, in which case every object would be able to look up and see the changed data. The data is in common. And class methods we can do real quickly. And by the way, today we get to explain what this whole row object thing is that we start our classes with. So if we want access to the class, we should probably pass it. And the default is to use, again, an argument that is named nicely, CLS. This is not syntactically enforced. But again, if you write class methods and the first object is, or the first argument is called foo, then other people might hit you. There is no row X. Tell you. Try this one more time. OK, so I've written a class. It has a class method. And that class method is a function whose first argument is the class. And it takes a value, and it sets the value on the class. And when I instantiate objects, we can see that we are, in fact, changing common data that's shared between the objects. Games. Games are kind of fun to play around with. And I've written a bunch of games with a Python library called Pygame. There's another one called Pyglet that I'm supposedly transitioning to. But they let you write simple 2D games in 100 lines of code, stuff like our address book. You can write simple 2D games. If you want to do 3D and you want to do very much hardware enhancement, things get more complicated. But to write simple games, I've written games for my kids. I wrote like a typing game and a math game for my daughter. You know, bubbles fly across a screen with math problems, and you type the answer on the keypad, and the bubbles pop, that sort of thing. It's fun to be able to do that in 20 lines in 15 minutes. But very frequently, if your game is at all complex, you have tons and tons of objects. Everything in your gaming environment might be an object. Your player, all the enemies, all the sprites moving around the screen. And I've used class variables as a way to do method passing to all the objects that are of the same type. So if, for instance, I've won the level and all the enemies in my space game should blow up, I might just set a variable called destruct on the class for enemies, and all the different kinds of enemies, ships, people, whatever, notice that they're supposed to be destructing and start blowing themselves up. It's a way to do message passing to a bunch of stuff instead of having to reach out to each individual one and tell it. So shared data, it's useful. The other decorator that I wanted to show you is going to skip ahead just a bit to the section called Encapsulation. We're still not talking about inheritance. I'm going to do that afterwards. But section 16.7 in your curriculum has 3 different ways of implementing encapsulation on our Python objects. And encapsulation basically is the object-oriented principle that how you do something should be hidden from the end user of your class. You should just expose that you do something. And what that means is the implementation details can change, but how your object is used might remain exactly the same. And I gave the example yesterday of your address book scaling. If you are exposing all your data as a list for our toy programs, that's fine. And you implement searching by searching over the list, and that's fine. Maybe you want to store your data in a database. If all the access to your address book is happening through address book methods and row methods, you can change the fact that your address book is storing them in a list to the fact that your address book is looking them up in a database without changing any of the methods, and the program that uses your objects doesn't have to know about it. The concept of coupling is involved here, tight versus loose coupling. And basically, objects should be able to use one another without knowing very much about one another. So as an example, when I say I want to represent a row, if my address book says print %s, 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 first name, last name, role of my row, my address book knows a lot about my row object. It knows that it has 3 fields. It knows what the names of the 3 fields are. If I ever change the 3 fields, I have to change my address book class. If, on the other hand, my address book class just says print row, and we delegate that printing operation to the string, the Dunder string method, my address book doesn't know anything about row. And when row starts adding fields, or row decides that we want to show a fixed width format instead of an English sentence, the address book doesn't change. So what it does, display a row, is completely separate from the implementation, and row hides that from the address book, if possible. It should be the relationship between all of your objects. When you have one object that is poking deeply into the data structures of another object, they're tightly coupled. If you change one, you're going to have to change the other. You make one small change to one object, it may cascade up a chain of 3 or 4 other objects that are not directly related, but which use it. And we'd like to prevent that from happening. So we have encapsulation, and we already have a basic level of encapsulation, which is we can just make you do everything through functions. Yes, we may have data structures, but do functions. And we can emulate various operators to make that nicer. So we can emulate iteration and hide from you whether we're storing things in a list or storing things in a database. And when you iterate over us, we'll pull them from a list or pull them from a database and you don't know which. And that's kind of one level of encapsulation that's useful. But we can also fake some things about our objects. And there's 3 ways of faking things about the properties of our objects. I'm going to tell you about one in detail, but I'm going to mention all 3. The first one is that we can intercept attribute access. And attribute access is the dot operator. The dot says, what comes next is a variable, but I want to look this variable up in the namespace before the dot. So in this case, the namespace before the dot is an object. And when I say r.x, it looks up x in the namespace of the object. It happens that it doesn't find it, but objects look at their enclosing class namespace and does find it there and returns it to us. We can use the __get_attr method to respond to the dot object, which is the most flexible way of doing encapsulation, but also way overkill for most of what we want. And what it means is every single time we use the dot operator, instead of going to look for the field, it'll call our function and pass it the name that it's trying to look up and let us decide whether that name should be looked up and where it should be looked up. And it's probably not what we want. It's probably a little too powerful. The simpler use case is to use a concept called properties. Anybody done any Java programming in here? So Java, it's very frequent to write getters and setters for the properties on your objects. You don't let somebody directly say row.x and x is an int. You'd probably say something like row.getX to get the value. And if you're going to assign to it, you'd probably say row.setX and pass a value. And the idea is encapsulation. You're hiding the data type of your underlying property. It's programmability. Let's say that we want our object to do something every time x changes. If we start out with x as a simple integer and we set the integer, we have no way of responding to that operation. So it's very common in Java to hide every single attribute access behind getters and setters. Python has the idea of getters and setters, but in a more flexible implementation. So let's write a property. OK, so I've got a class AB for address book. I'm defining my init function. It takes self, it takes data. It's just setting data to a object level variable. And I've got another variable called numRows that I get from calculating the length of data. I'd like to expose, I have in fact exposed numRows right now. Obviously, I'm not passing real address book data here, but I can see numRows. If I want to take some sort of action, or I want to do some sort of filtering anytime somebody looks up numRows, I can use a property. I'm going to hide numRows slightly. Python has no concept of private variables. It is convention to use a leading underscore for variables you do not intend people to directly access. And what this basically communicates is, hey, if you're peeking at my underscore variables, you may not know what you're doing. They may or may not be accurate. This isn't the way you're supposed to use them. It does have data mangling that we'll talk about in a little bit.
That's just a common practice.
That's a convention, not syntactically enforced.
Variables defined under static method, functions will be shared by all the objects calling that functions.
No, what makes the difference is whether you set it on the class or whether you set it on the object. So back in our class method, the first parameter that came in wasn't self. It wasn't an object. It was class. It was the class. And so saying back then cls.x is no different than saying row.x. And remember, row is a class. So class variables are shared between all the instances of the object.
Right.
No, so if you say self.x inside of a bound method, a regular class method, you're changing objects in the object namespace, and they're different for each object. If you use a class method, and I could have hard-coded the name of the class inside my class method and said row.x instead of accepting it as a parameter. But as we'll see in a little while, sometimes methods don't know what class it is that they belong to. We'll see that. OK, so back to my example with a property here. I've got A. And if you look at A, I see I have numRows, and I also have data, and I have underscore numRows. And what is numRows? It was a function, right? It's this piece right here. And when I say r.numRows, I would think I would see like a function object. As for instance, I say r.init. It's a function. It's a bound method, but it's ultimately a function. But when I say r.numRows, when I say a.numRows, it calls my function, even though I didn't use any parentheses, and it returns my value. So what the property decorator does is let you pretend that your function is an attribute. And the default thing the property does is handle the lookup of your attribute. And you can do whatever you want with the lookup of your attribute. You can keep people from looking at your attribute. You can delegate it in some way. You can access the hidden variable, which is what I'm doing. And I'm also just printing you peeked. This is different than making a normal function because it is not really numRows that's being called. It's the decorator property. If you remember decorators, they wrap the function, they do something, and then they call the original function. That's what's happening. And let me switch over to my text editor to do a slightly longer example. I don't know. So there's no syntactic relationship between numRows and a_numRows. It doesn't figure out that what you really mean is this private variable. It leaves the implementation of the property completely up to you. And let me experiment with that double callback thing, but let me also show the other part of the property here. So we have our address book class. And then the interesting thing about properties is when you call @property on a function, @property does more than one thing. It does wrap the function. It also creates some new variables that you can access. And those variables are named for your function and provide a list of other decorators that you can use. To handle setting as well as looking up. So let's see if this works. And that's what I thought. The fact that I'm getting it twice is an interface between IPython and my Python, between IPython and Python, the runtime engine. I'm not sure why IPython is echoing it again, but if I run it just from the command line, I'm initializing it the same way. I'm accessing my property. And it only prints it once. And I could say, so it's an IPython thing, and I'm not sure why.
In my test here, the num property doesn't show up at all.
OK, let me come look at that in just a second. But let's also note, it already is 10. I just said a.numRow equals 1. And again, if you think about the code that I'm actually writing, it seems like I'm assigning to a function variable. And it also seems like I have two defs with the exact same name. But what's happening here is @property has completely taken away this def numRows function, replacing it with its own thing, and is intercepting attribute access to numRows. at property numRows.setter is completely taking away, again, my attempt to define numRows, and is replacing it with access to the property numRow and responding to the equals operator. There's some cool OOP magic going on behind the scenes. The first property encapsulation that I said was too powerful is what the properties are using. And emulation to respond to operators, like the equal sign, is what those decorators are using, the property decorators are using. And it would be complicated to write them, but we don't have to write them, and it's relatively straightforward to use them. My first function is the name of my attribute, and it gets the app property decorator. About half the time, that's all you need to do, because you just want to do something when somebody looks up a value. For instance, maybe if you're storing your records in the database, you don't keep a number that says how many there are, because multiple programs could be using the database. And when someone checks numRows, you go ask the database how many there are, and you return the number. But again, the end script doesn't know what the actual implementation of numRows is. It can just directly use it. As far as it's concerned, it's just a number on the class, even though what it really is a function that calls the database and asks the database how many rows there are. And you can change how it works without changing the interface that you present to your using program. Sometimes you do want to intercept setting it, and setting the number of rows doesn't make any sense particularly. So don't get lost on that. I'm just demonstrating that anytime you define the property, anytime you use the property decorator, it dynamically creates for you new decorators that didn't exist until you used it. And their name is at your property, which in this case is numRows, and then dot, and I believe there are actually 4 of them. But usually we'll just use dot setter because what we want to intercept is attribute setting as well as attribute access. And it works as I want it to work. I can say a.numRows, and it prints out something's happening. Again, I don't know why it's printing twice, but it's an IPython thing, not a Python thing. So I'm not too concerned. And it returns the value, and I can assign a new value. And again, some extra code is happening, but it is setting the value. So I've wrapped some potentially complicated code around what looks like direct attribute access.
So if you don't do any assignments, it's going to call the okay.
And what's really cool about this, as opposed to the Java way of handling getters and setters, is with the Java way, you need to remember to do this at the very beginning. The first thing you need to do is write all your getter and setter rows. And lots of Java IDEs like Eclipse will automatically let you say, here's my class, and it's got 10 properties. Go ahead and make the get name, set name functions for all of them, and then I'll fill them out. Poof, it makes 20 functions for you. Because you need to do that right away. If the users get used to saying .name, you've got no way of intercepting that later on. We can directly expose numRows as a property, just a simple property initially. And if later on we decide, hey, we need to change it, we can use the property decorator to introduce a function into the mix. And as far as the user knows, they're still directly accessing that attribute. We're not forced to start from the very beginning being as complicated as we'll eventually need to be. We can change the implementation later on, but the interface to the user still just looks like .x. As far as they know, they're just looking at an attribute on your object.
You know,
just one to get it.
The first one is basic one, but usually.
But if you want to get it and set it, 2.
Okay, so 2. Anything more, or is it only?
I believe the property decorator automatically creates a couple of other decorators for you. And let me look that up in my Python in a nutshell so that I steer you exactly right, because I never use the other ones. That's why I never use. There's also a decorator for deletion, and that handles if you say del, the built-in function del lets us actually delete variables. So we can delete variables from our local namespace. We can remove variables from a list. We can delete variables out of our dictionary. I know I've done that with a couple people. If you actually wanted to get something out of your dictionary, you can't just assign it to none or a blank string. The key still exists. If you want to get rid of it, you can say del Dict brackets label, and it's gone. there's a property that allows your attribute on your object to respond to the del function as well. I've never done that. I don't know why you would delete an attribute on your object, since in general you want all of your objects to have a consistent interface. But you can do it, and there's also one for doc, so you can handle retrieving the doc string on your property. And I haven't used that one either. So yeah, most of the time you just need to write two functions, one for getting, one for setting. Yuli, you're trying things along as you go, and are they working? They're working?
I'm fine, the indenting again.
Okay. There is one other emulation topic, and this one I'm really going to skip. So the first one I said was so powerful you rarely need to use it, and it is the getAttr _ method. And that method will get called every time you access any property, no matter what its name on your object, and allow you to do anything you want. And we usually, we don't want that most of the time. I mean, usually we've got functions, we want people just to call them. We've got some attributes, we want people just to be able to access them. It's too powerful. The middle ground is the property decorator that we're using, and so just for the attributes that we're interested in preserving, protecting. So for instance, this way you can make read-only attributes, right? You could store numRows as an int, but you could leave off the function that assigns to it, or you could write the function that assigns to it and have it return an exception that says, I'm sorry, you're not allowed to set numRows. That's a read-only property. Right, so we can modify access to a particular variable by writing our property functions and using the property decorators. And then there's a final there's a final encapsulation method called Descriptors. And descriptors basically involve making the attributes of our class a special kind of class Python defines for us. That once again lets us wrap access to our class in some other functionality. And I find descriptors, again, usually to be overkill. They do change how your object is inherited. That's handled differently from properties, which is one of the reasons for using them. But we don't know what inheritance is yet, so I can't even discuss why you might possibly want to use descriptors. And it's finally time to discuss inheritance. So the second part of OOP. Think about the classmates project that we've been working on. And we have rows in an address book, and every row is first name, last name, and role. Let's say you wanted to use this to organize all of your contacts in your life. Your Facebook friends, your Google Plus friends, your family, your cell phone numbers. It'd be a lot of data. And the data wouldn't look the same, necessarily. Like, for a lot of people, you want to store things like their Twitter account, their website, their phone number. For cell phone contacts, the most important thing is probably their phone number and their first and last name. For family, maybe you want to print the relationship and their first and last name. For celebrities you're keeping in the database, maybe you want to print notable information about them, some sort of bio. So all your rows might look different. And kind of with the single row object that we have, the way we could handle that use case is to just start putting lots of fields on our row. Right? Every row could have first name, last name, Twitter, website, home number, cell phone number, relationship. But when you print them out, if we're using the _string method to get a string representation, they'd all print out exactly the same way. And it'd be really nice to print differently depending on what kind of object they are. And we can start to do that since we're using a method by saying, OK, what kind of object are you? And I'll use a different format string in different fields. But that could get a little bit complex. Really basic to OOP, and kind of the second major reason to use OOP. The first reason is, hey, we can group some methods and some data together. The second reason is we can create hierarchies of related objects that share functionality that's shared, but that implement functionality that's different themselves. what did I do? I'm defining a class like we have been, and I said every class should take object. The parameters that you pass to your class definition are the objects that it inherits from. And I'll explain what inheritance is. It is a valid Python statement to have a class that doesn't inherit from anything, but that's only there for backwards compatibility. I believe it's removed in Python 3. And originally in Python, like in many programming languages, there was a distinction between base types and complex types. Base types were not objects, and complex types were objects. That turns out to make things clunky for the user. And Python, the language, was changed so that every single type in Python inherits from a base type of object. Everything is an object. And that unification is really nice. This definition of row without an object will not get you a syntax error, but it gives you an old-style class that's slightly different than all the other classes, all the other objects. It will produce objects that are slightly different than all the other objects, and is always an error. So you should always inherit from object or another class. And my second class, I made a class called student, and it inherits from row. What does it mean that it inherits from row? OK, exactly right. Row, getting the right console here. Row accepts some data. With an init function and sets a local member data. You notice my implementation of student, I didn't actually do anything at all besides inherit from row so far. I didn't even provide an init function. And yet, I'm calling the init function and passing it data, and the data exists. So how inheritance works is it modifies our lookup. So on an object, if I call a method, it looks in its local namespace to see if the method is defined. If the method is not defined, it looks up the inheritance tree to find the method. And if it exists, it calls it. So for instance, when I say stir s, what Python is doing is saying, OK, I have an object. It's of type student. It's had the string operator called on it. So I'm going to call its __str function. It doesn't have an __str function. But it inherits from row. I'll look in row and see if it has an __str function. Row does not have an __str function. Row inherits from object, so I'll look in object. Oh, object provides the default implementation of that Dunder method. Is just to print out a programmable representation. It's actually calling repr, which tells you that this is a module oop, class student, instantiated object, and print its ID. OK, this is method delegation, and it's a big part of the point of inheritance. We will also share variables, but we'll be sharing class variables. And I made one comment earlier. The reason we have class methods and the class accepts the class that it's attached to, the class method accepts the class that it's attached to as the first parameter is because it's possible that you have a function that doesn't know what class it's being called on. And that's because when we call a method on an object, we might not get a method that was defined on that object. We might get a method that was defined on an object someplace up the inheritance tree. So let's do a couple things with inheritance here. If the point of this is to make rows that are different types and accept different fields, we could define inits for each type and accept only the specific fields we want. But that would mean initializing like this. But that would mean that people would need to know how to construct the different instances of our objects. They'd know about our implementation. So let's not supply any inits. Just pass this for now. So I'm barely implementing things here. But I've made a default class called row. Its init just accepts the tuple or the list that we've been reading and writing from. And that seems like a convenient data interchange format because we're going to get a tuple or a list from our CSV file or from a database. And we're just going to store that data. We could use properties to give us convenient access to the data. When we started to rewrite our address book program, our classmates program, with objects, we noticed it's a lot more convenient to say if row.roll equals roll than to say if row brackets 2 equals roll. So we like having names. Let's preserve the names. But that doesn't mean that we actually have to load the data into the proper field. We can just use property to expose the appropriate index. Student is going to work the same way. Presumably, we'd write properties to set the first name as well, a property for a last name and a role. Celebrity has got a property, Twitter, that's going to return the 4th column of our data. And we're not defining that for student or for row.
And because all of those are separate classes, they all have to be imported independently?
Yes.
So, I mean, aren't you using just as much code there? I mean, it's not changing code because you're importing it all and reading your file, but that means that every time, if you were going to break up the data like that, you'd end up with a big chunk of code falling off.
So what I would do, well, yeah, I can do this. I'm not super concerned about the whole module level versus top level naming structure, because what I would probably define is a dictionary that maps a role name to the appropriate row object. And any role names that aren't found should just be default rows. And then when I get a new line as I read my data, I can look at the role and say, is this a role I have a special class for? If it is, let's make a new one of those. If it's not, let's just make a default row. So I can store functions in data structures I can also store classes in data structures. And just like we made menus that had a key-based lookup and you call the appropriate function, I could make a dict that has a key-based lookup and instantiate the appropriate object by storing the class as a variable. One class has to be defined before it can be inherited from another class. So the order of the classes do matter if we're doing inheritance. It is. CSS has classes. They're not OOP-style classes, but they are things that denote categories of objects which will have implementation details in common. It also has IDs, and that's a little bit more like a specific object. So you can write rules in CSS that are common to all objects of a particular kind, and then you can customize the details of the first and the last one and the one with a particular name. Yeah. It's the same sort of technique. We're writing code that's going to be similar for all of them on our row. And code that might be specific to the implementation of this particular kind of thing right on its object. So remember how method delegation works. If I try to convert a celebrity to a string, it's looking for the underscore underscore string method on that object itself. And if it finds it, it calls it.
It's looking for the first thing, the closest namespace it can go to.
Yep. If it doesn't find it, it will go up the inheritance tree. And this is a good quick point. The code that I have up, again, this isn't syntactically enforced, but you'll run into problems when you try. The property function that just uses the plain property decorator obviously has self, the mandatory first argument, which is the reference to the object the method is attached to. But the setter will be passed an argument, and if you don't supply x here, when you try to set it, you'll get an error. It'll say, I tried to call a function, and I tried to pass it 2 arguments, and it only accepts 1. And that'll look kind of weird to you because you think you're just setting an attribute, so that error message isn't super helpful. But underlying everything, it's calling this numRows function and trying to pass it an argument. So last thing here on classes, before I turn you loose to work on labs for a while, is that sadly we can inherit from more than one class at a time. The syntax for doing that is just a comma and additional types. And you can inherit from as many classes as you want. The main complication this provides is that method delegation now gets more complicated. When I say call a method on my object, and if my object doesn't implement it, look up that object on all the classes that I inherit from, it has a particular order. It goes as you would expect in order of declaration. So the method resolution order, MRO, you'll see that abbreviation sometimes, is depth first and from left to right. If you don't use multiple inheritance, or you only use it in one limited use case, which I will explain in a moment, you don't need to worry about this. If you do try to use multiple inheritance, you will inevitably at some point get to, you're calling a function, you know that it exists in some object that you're inheriting from, but you're getting some other object's function. and you're trying to figure out why. Notice I'm also getting a violation when I try to inherit from object and something else that's inheriting from object, and it complained about my MRO. That's that method resolution order. And basically, if you're inheriting from another new class that already inherits from object, you don't need to inherit from object yourself. The only reason we inherit from object is to make clear that we're a new style class. Everything is an object. But if I'm inheriting from object, it's not just redundant, but wrong to say my student is an object and it is a row, because row is an object as well. I can, however, inherit from two classes. This is a stupid example, because there's no point to saying a celebrity is a student and is an address book. I don't think. I did it nevertheless.
Which one you're saying that was cannot be done? A role, the object and the role. Why that cannot be done? Object.
So if I say this, that's multiple inheritance from object, which is the built-in base class, and row. But row already is an object, and the only reason we provide object on our list of inheritance is to specify that we're a new style class. So if we inherit from any other class that is a new style class, we don't need to inherit from object. We do, but we also inherit everything that row itself inherited. And row inherits a bunch of methods from object.
Right.
So when I say I inherit from object and I inherit from row, it's a duplication, and it's noting that when I go to look up methods.
Okay, I got you. No, I got you. I'm sorry. Okay.
Even with student address book, though, it's still those are inheriting from object. So it kind of resolves down to the same thing.
It does, and it's basically why object is sort of a special case. It's the only one Python will do this checking for, although it will complain about the method resolution if you make some other obvious multiple inheritance mistakes, because object is the base class for everything. So since I said celebrity is a student and an address book, if I'm confused about how it's calling methods and saying which method is actually being called here, I can look at the Dunder MRO item on my class, and it gives me a list in order of how it would look up methods. So if I call any random method, it will first look to see if that method belongs to celebrity. Celebrity inherits from student and AB. It goes leftmost and says, OK, I would look at student next to see if the method was defined. Student inherits from row. It goes leftmost. In this case, there's only one, but it goes leftmost and depth first, and looks down to row. If it still didn't find it, it would come back and take the next class in line. Why didn't it go to object if it's depth first? Again, object is a special case. Object is the base class. It knows when it has reached object that it will stop. So it comes back and takes the next class and looks in AB. AB doesn't inherit from anything else, just object. And it's looked at all of my multiply inherited classes, so it will check object and stop. So you can look at the MRO to see exactly how it is that Python's figuring out which class your method should be called from. But if you ever find yourself looking at the MRO to figure this out, it's a clear sign you're doing it wrong. People argue as to whether multiple inheritance is a good idea or a bad design decision. In some languages, outlaw it completely. So Java, for instance, is a very object-oriented language, much more so than Python. Everything is an object in Python. There is no concept of simple types exactly. There is no procedural programming in Java, but Java has only single inheritance. I would encourage you not to use multiple inheritance except in one limited use case, which we'd call mix-ins. Mix-ins are not syntactically defined, but the idea is you might have some functions that you want to apply to a bunch of different kinds of classes. Method resolution order. So for instance, we've kind of talked a couple times about logging. You might want your class, every class, whether it's an address book or whether it's a row or a student or a celebrity, to have a function called logit. And you could get that by having them all inherit from a new class called logging class. This does not imply that a celebrity is a log in the same way that it implies a celebrity is a row. You're using inheritance typically to group things into hierarchical relationships. A celebrity is a row. A student, it is a row. That relationship indicates fundamentally what its type is. If you inherited from a logging class, you're not really indicating that it is a log. And you might not share any data whatsoever. You might only provide a couple of utility functions. Other languages have special syntax for this kind of inheritance and call it a mix-in. And sometimes you'll hear Python programmers say, well, I'm using multiple inheritance, but this other class is basically just a mix-in. And what they mean to say is that class defines functions that no other class will. It's not going to have any MRO confusion. It's just a way to get a function onto this class that I want to call. And that's kind of a safe use of multiple inheritance. If you draw diagrams of your class hierarchy and every class is inheriting from 3 different kinds of classes, you will get in trouble. You will find points where you can't figure out what's going on, and multiple inheritance is just basically dangerous. So use single inheritance, maybe occasionally use multiple inheritance just for a little extra functionality on your classes, but primarily things are one kind of thing proceeding up hierarchically, not like 4 kinds of things, for your own sanity's sake. OK, so that's all the OOP syntax that we need to do. I'd like to turn you loose on our lab for a little bit. We can complete what we were starting yesterday, and I was kind of getting around to everybody, which is refactoring our address book to use objects. Mixing? Yeah, so with mix-ins, I'm just saying it's not fundamentally expressing a relationship where I'll access lots of stuff based on the base classes. With inheritance, you're usually saying, like, most of my functionality is in the base classes, and then I'm customizing or overriding the little bits that are specific to me. Right. With a mix-in, you're actually saying, I'm not customizing or overriding anything, and all the functionality is in the base class, and I just want to grab a couple of functions and add them to my class.
It's more like addition.
It's more like addition.
Complementary things.
Yep.
That concept is called a mixing.
Yes.
Okay.
Yes.
It's not overriding ones.
Yes.
Okay.
And you could always do that by composition of objects, which is you could pass all these different kinds of objects a logging class in their init function, and they could all have a single function that calls the logging class to do whatever logging it is that you want to do. But that's a little bit of extra glue code. So if you just wanted to inherit from a mix-in class, that might be OK and acceptable use of multiple inheritance that won't come back to bite you in the butt too badly, probably. So I was going to have you, I was making the rounds, and some of you are well started on using objects in your address book. For those of you who are well started, I'd like to suggest that you try a little bit of inheritance. So I'm going to put 2 assignments up. If you're still working on the first one, that's fine. If you feel like you've got a handle on Lab 15 and you want to move on to Lab 16, that would be great, and I'll come around and see where everybody is. The point of Lab 15 is basically we were refactoring our program to use objects. You can decide whether your address book should be an object or not, but definitely your rows should be an object, and they should know how to do things like sort themselves and print themselves. I might talk about that a little bit further. Knowing how to sort themselves is a matter of implementing the __CMP for compare method. And if you do implement that method and you call sort on a list that contains your objects, the CMP method says, given 2 of my objects, which one should be first or last. And you can do things like simply return a comparison of the last name. And then you could sort your list of objects by last name just by calling sort on your list that contains them. Optionally, I guess, the address book should be an object that knows how to print itself and add new rows. And then if you want to get slightly more adventurous, with Lab 16, let's add some fields. Let's add some types. Let's think about storing more than just students and instructors in your address book. And you might have different representations and be interested in different fields. So play with inheritance a little bit to implement that.